Before we begin looking at section 6.2 in our textbook, I thought it would be a good idea to compare and contrast the two inferential statistics techniques that we will now be applying to the case of two proportions, namely confidence intervals and hypothesis testing. So let's now see how we will apply our two inferential statistics techniques of constructing confidence intervals and running hypothesis tests to two proportions. First of all, for a confidence interval with two proportions, that will be used as a means of providing an estimate for the difference of two population proportions. Here's an example of how we might do that. Suppose I want to estimate the difference in proportions of California voters and Nevada voters that voted for candidate XYZ in the popular vote for the last presidential election. In contrast with that, for hypothesis tests, we're going to use that as a means of testing a statement or a claim regarding the difference of two population proportions. And here's an example where we might want to do that. Suppose I want to test whether there is a significant difference in proportions of drug trial participants that took a drug being tested versus those that took a placebo. Continuing with our comparison and contrast of the two inferential statistics techniques for two proportions, note that for confidence intervals, all formula in sketchwork is going to involve the sample proportions as our key values. In contrast with that, for hypothesis tests, when the null hypothesis is that the difference of the population proportions is equal to 0, then all formula and sketchwork will involve what is known as the pooled proportion as the key value. Sketches for confidence intervals with two proportions are going to be geared towards creating a shaded interval, just like they were when we constructed confidence intervals for single proportion. In contrast with that, sketches for hypothesis tests are geared toward creating shaded symmetric tail areas that represent the p or probability value. And again, that's the same as what we did when we were working with one proportion hypothesis tests. So the last thing we want to take note of as we look at the two inferential statistics techniques that we are now going to apply to two proportions is that both of them are going to use the exact same four-step processes that we developed for confidence intervals and hypothesis tests back in Chapter 5. So for confidence intervals, that means four-step process for constructing an interval. For hypothesis tests for two proportions, that means using a four-step process for evaluating the null hypothesis with the p or probability value. And again, the steps are exactly the same as we've seen before for both of them. There's a prepare step, a check step, a calculate step involving an appropriate sketch, and then lastly a conclude step at the end of the process.